Good evening, everyone. It's great to be here, and I'm looking forward to a great presentation. I want to introduce our speaker this evening, Dr. Marcelo Gleiser. Dr. Gleiser is one of my heroes, and it's just a huge honor for me to introduce him this evening. He's the Appleton Professor of Natural Philosophy and a Professor of Physics and Astronomy at Dartmouth. And in 2019, he was awarded the Templeton Prize, an honor that he shares with Mother Teresa, Archbishop Desmond Tutu, the Dalai Lama, and scientists Freeman, Dyson, and Martin Rees. It's a pretty big honor. Dr. Gleiser's books have been published in 15 languages and include The Island of Knowledge, The Limits of Science and the Search for Meaning, A Tear at the Edge of Creation, and The Simple Beauty of the Unexpected. He's a world-renowned theoretical physicist interested in cosmology and astrobiology, and he's published hundreds of peer-reviewed articles and more than 1,000 essays and op-eds. You may have seen him in one of the many TV documentaries and radio shows that he's been in around the world. And he co-founded 13.7, the NPR blog on science and culture, which is where I first encountered and fell in love with his writings and his work. He currently directs the Institute for Cross-Disciplinary Engagement at Dartmouth College and writes weekly for Orbiter magazine. I could go on, but we want to hear from him. So without further ado, Dr. Gleiser, please take it away.
Okay, well, hi everyone, and I'm very glad to have such a nice and big group of people listening tonight. I'm very excited to be speaking to IRAS and the community. There was supposed to be a visit of mine to one of your events at the island, at the Star Island, but because of COVID, the whole thing fell apart, unfortunately. But one day, I hope it will still happen. So the topic of tonight is, let me say, a very hefty topic, but also one that I hope will be fascinating and interesting to all of you, which is, what is the nature of reality and how much can we actually tell about that nature of reality using the tools of humans, which is, our imagination, our reason, and of course, our scientific developments that kind of tell a story of what this reality is all about, right? And I think it is the subtitle that tells you a little bit about what the gist of this conversation is going to be like, which is really, despite the spectacular power of science, and of course, I've been a practitioner for pretty much all of my career, and I am a big defender and spokesperson for science, we also have to understand that science has limits, and it's kind of fascinating to discuss those limits because they tell us so much about what it means to be human in a universe full of mysteries, right? So that's what I want to go today. And I would like to start by quoting one of my heroes, and I didn't know, JD, thank you very much for that comment, but one of my heroes, of course, is Albert Einstein, and he has wonderful quotes. This one in particular is, I think, phenomenal because it goes right to the point. What he says is, what I see in nature is a magnificent structure that we can comprehend only very imperfectly, and that must fill a thinking person with a feeling of humility. So there is so much packed into that, but what he is trying to tell us with this is that there is a spiritual connection here with nature as a magnificent structure that we can only apprehend to a certain extent. So this notion that even one of the greatest scientists of all time, it's telling us that we humans can only see partly into things, is indeed an invitation to feel humble about what we know and also about what we don't know, right? And that's it's so common, for us to kind of get carried away with the truth of our arguments. And perhaps one of the great lessons that science has to teach us is that truth is a very loaded word, and it has to be taken with a very big grain of salt. All right, so, and we are going to go into that as we move along. And I want to bring in something else that he wrote, which is the fairest things we can experience is the mysterious. It is the fundamental emotion which stands at the cradle of true art and science. And he who does not know it and can no longer wonder is as good as dead. He goes on to say, is like a snuffed out candle. So again, this is pointing to pretty much the core emotion of what being human means, which is this fascination with this mystery, our capacity for wonderment, what we sometimes call the awe of perceiving reality and understanding that we are a very deep part of this reality, but also that it is surrounded, enshrined by mystery, right? And one of the greatest missions, so to speak, or quests, if you want, of the human mind is precisely to go through those veils that separate us and whatever is at the fundamental level of reality, and try to come as close as we can to that, right? And so this I call it a flirt with the unknown, right? So, and this flirt with the unknown is precisely what drives human creativity in many, many different endeavors, from science to the arts and many, many others that we may comment today during this conversation. And I like to put this quote from Einstein with this picture, right? And you look at that picture, and at least when I see it, I feel really sorry for the fish. There is the poor fish. It is constrained within its little fish bowl, right? And the perversity of the picture is that it does have this whole ocean in front of it, right? And it could, I assume, see through the glass, understand that there is this ocean that represents so much more, this expansive reality of possibilities. And yet, if he jumps out, especially when the tide is low, like in this picture, it will die, right? But if it's smart enough, it will wait till the tide is high, and then maybe it will jump and survive and be able to explore much more of reality. And then you say, well, but who is this fish really? And this fish is essentially a metaphor for us humans. Of course, the photographer that took this picture must have said, I'm going to come up with a narrative here that kind of represents how much more, well, there's beauty in this, but there is also the power of us human to put this fish into this situation. But yet, the point is that we are also the fish, because we are also part of this community of living creatures where we understand reality. Obviously, different animals understand it in very, very different ways, right? And we could go into that a little bit later when we talk about consciousness. But the point is that we all have our limits of perceptions. We are all within our fish bowls, right? And what science can do is perhaps expand a little bit the reach or the size of the fish bowl so that we can see a little beyond what we can through our senses, but our vision is never going to be perfect. And again, we question what is the nature of reality, right? Because I ask you right now, right? You're watching this in your computer screen, and you can see me, and you can hear me, and you can feel the chair you're sitting on, right? And you're breathing the air around you. And based on this sensory input, your brain collects this information and creates what we could call the feeling of being present in the world, what we call the reality of things. So you look around and you can expand your view of what's going on, but this is reality. But really, it's only a very, very tiny sliver of reality, because there's so much more that is going on around you right now that you're not able to perceive, simply because the human senses were not evolved through millions of years of evolution to see in the infrared, to see in the ultraviolet. to hear noises beyond our auditory range, and so on and so forth. We cannot see the atoms that make up what's going on around us and what's even what makes us up, right? And so there are limits, right? And this is an essential point. What we call reality, right, is really a very limited part, or what we can translate of reality according to the way we understand it, and we scrutinize it, and we probe it, right? And here are two more amazing quotes. This one is from Werner Heisenberg, that says something very much to the point of what I'm saying here, which is what we observe is not nature itself, but nature exposed to our method of questioning. This is a very profound statement. And of course, Heisenberg, being the one that, as you probably know, was responsible for the uncertainty principle of quantum physics, was very much amazed and puzzled and perplexed, like a whole generation of physicists in the early decades of the 20th century, when they had to deal with the mystery of quantum, right? The notion that when you look at the world of the very small, reality, or what we call reality, behaves in very, very different ways than it does around us. So, you know, if I pick up a pen, right, I can see this pen in my hand, I can feel how solid it is. If I drop it, it's going to fall down due to gravity. And all these are perfectly fine things. But if you go and you say, okay, what if I could see what electrons were doing right now? And what we would find out is that the rules, the laws that describe the behavior of very small objects, molecular, atomic, subatomic particles, they are very different than the laws of what we see around us. And that behavior, which was essentially exposed by this to this group of brilliant scientists through their experiments, through their method of questioning, reveal a world which is alien to this world, right? And that to me is an essential point, is that we are asking questions of nature, but the questions that we are asking are very much framed by the kinds of creatures we are, right? So you could speculate that a different alien intelligence would be asking questions about nature, which would be essentially quite different from the ones we ask, for many, many reasons, right? Including the fact that they certainly evolved in a very different environment. And obviously, the way you evolve in an environment, certainly at the history of life on Earth, kind of frames the way you interact with the environment and the questions which are important for you to ask within that environment. And then the clincher is not a quote from somebody like Einstein or Heisenberg, but from somebody else who is actually a philosopher from the 17th century who published a book, which is this magnificent book called A Conversation on the Plurality of Worlds. And the name of this philosopher is Bernard Le Bovier de Fontenelle. And he published this book in 1686. 1 year before Newton published his magnum opus, the mathematical principles of natural philosophy, where he develops the laws of motion and he develops the law of universal gravity. So that was like a landmark book that essentially changed the world. Well, in France, a year before, Bernard Le Bovier de Fontenelle was interested in other worlds. Why? Well, because he was a child of the Copernican revolution, and he knew that Earth was only a planet. And if Earth was only a planet, if there was life here, why not in other worlds? So this kind of conversation was already super popular in the 17th century. And he wrote this book, which was a very interesting book because it is a conversation between a philosopher, natural philosopher, which essentially is the name for scientists in those days, and a marquise, so a woman protagonist, which was very rare in 17th century literature, where she asks him all sorts of questions about how do you know about kinds of life that could be out there, about the moon, Mars, etc. And at some point, she asks the philosopher, but what is philosophy? right? And this is what the philosopher answers. He says that all philosophy is based on two things only: curiosity and poor eyesight, which is brilliant, because what it's telling us is that, yes, we humans are very curious. We want to know more and more about the world, about reality, and we keep asking questions, and we keep trying to see more, which is precisely why we're motivated to ask these questions. However, we are always short-sighted, right? So even if we improve our reach into the unknown, there's always going to be stuff that we cannot see. So this tension between our curiosity and our limited ability to find answers to all our questions, right? There's a tension there, clearly, is, in my opinion, a very wonderful thing, because this is what drives the creative spirit of humans to expand our horizons, right? So, you know, kudos to the Fontenelle for kind of summarizing so well, I think, what is going on. But this adventure, right? Because we can call it an adventure of knowledge, right? I mean, how we going from, you know, hunter-gatherers at 40,000 years ago evolved in terms of our curiosity and representation of the world, right? Starting with cave art, and even just the decorations of objects that were just useful, right? I mean, a question which I think is fascinating, which is related to this, is why did someone decide that if you get a pot of water, right, what is the function of the pot of water? Well, you know, the river is far away. I don't want to just go there and drink a little bit. So I create this utensil, right, this thing that can have a lot of water inside. And I go to the river and I fill it up and I bring it back to my village and we can all drink the water. It's a wonderful thing. But then somebody decided one day that why not draw a line along this object of use? And that was completely unnecessary from a pragmatic perspective, right? I mean, there's no use in that object having a decoration, a line, but that is art and the beginning of art, the expansion of our human engagement with the world and with emotions in ways which are abstract and not necessarily useful, but essential to our human spirit, right? And that is a transition that had happened already, you know, 20, 40,000 years ago, right? And this curiosity of expanding our reach into what we understand of the world through our artistic creations, and then through our philosophical speculations and our religious connection to the world, which is a whole other story. I could give a whole talk about how did that emerge and how does that connect with the scientific curiosity. Hint, hint, somebody could ask me that during the questions. But for the purpose of our conversation right now, the expansion of these sorts of questionings about what is the nature of the world and how do we know it, you know, had a huge jump in the Western world, at least in ancient Greece and with the pre-Socratic philosophers, but also with Plato, right? So Plato, who was very influenced by a few pre-Socratics like Pythagoras and Parmenides, etc., he, in the book 7 of the Republic, he comes with this very famous allegory called the allegory of the cave, right? And in the allegory of the cave, he wants to tell his readers that what we see of the world is not the world itself, is not the truth about the world, but is a deceiving conception of what's going on, right? And in order to do that, he comes with this allegory and says, imagine that you have a group of slaves, that's his narrative, that they were born in a way that they are all chained together, and all they can do, the only freedom they have, is to look forward to the cave wall. And what do they see on the cave wall? They see a bunch of images projected on the cave wall. They don't know where they come from. They don't even ask that question, because to them, the only connection to the real world is that cave wall. And hence, all the objects and creatures they are dancing on the cave wall, to them, that is reality, right? And he doesn't know, the slaves don't know, that behind them, because they can't turn back, right? So behind them, there is a group of people and a roaring fire, and the group of people are holding like, objects in front of the fire, like, they certainly weren't holding an iPhone, but they were holding cell phones in front of the fire. Certainly not, but statues and circles and little pieces of wood, and projecting those shadows on the wall. And so what the slaves were seeing were these shadows dancing on the wall, and to them, that was reality, right? And what Plato is trying to do with that is to say, do not be deceived by your senses. If you want to get to the truth of things, you should only believe in your mind, right? And so he talks about his theory of forms, where he says, the only perfections that you can contemplate are in the realm of ideas. So an example of that is, if I tell you, imagine a circle, right? If you imagine a circle, immediately you're going to see this image of a circle in your head. And to Plato, that was the only perfect circle that existed. If you try to represent that circle in the real world by drawing it, or now in modern times using some laser printer, that representation, that physical representation of an idea of a circle into the world is never perfect, right? And so he says, if you're going after the truth, beware of the senses. And this cartoon here is a combination of Plato's Cave and The Matrix. If you remember the movie The Matrix, it's kind of old now, but you have like Keanu Reeves as Neo, who is sort of like the savior. And in that case, you had machines, a whole artificial intelligence that enslaved humans and put them in pods, and basically were feeding their senses with a simulation of reality, right? And those people believed that was reality, and they were like really kind of thinking, whoa, this is my life, until Neo shows up, of course, and says, you know what? That is not reality. We are all prisoners here. There is no real free will. We are just part of this simulation of the world. And the Matrix is essentially a modern transposition of those ideas of Plato to our more technological world, right? So here you have one of the slaves telling Neo, it is prophesied that one day a chosen one among us will break free of this world and reveal to us the true nature of reality. The true nature of reality. That's a super loaded statement. And Neo says, that's very unlikely, right? I mean, it's not going to happen, right? Because how can you get there? So in a sense, it is a statement of Plato's notion, but Plato did believe, contrary to what we are going to argue, that there was such a thing, and that the true nature of reality was really in the realm of the human reason, right? Anyways, I want to then now illustrate some of these ideas with three different narratives that science constructs of reality, right? The cosmic narrative, the universe, and sort of like the astronomical aspects of reality. The material narrative, which is things are made of stuff, right? And what is that stuff? And finally, the cognitive reality of who we are and the nature of consciousness. And then I'm going to wrap up with some other notions that talk about the limits of our narratives, so to speak. So first of all, one of the beautiful things that science can do and does is it amplifies our grasp of reality through a whole gamut of instruments, right? So also in the 17th century, in the early 17th century, in 1609, Galileo got a telescope and was the first to have the idea to point the telescope up to the sky. And with that, for the first time in human history, astronomy got amplified from the human eye, which was the only way people were mapping the skies incredibly well. Even since the Babylonians, they were very observant of the motions of the planets in the sky because they were astrologers. They believed that the locations of the planets with respect to the constellations of the zodiac, right, the 12 constellations, had prophetic powers. And so the interpretation of those motions would then help, especially the rulers, know what to do, right? And astrology was essential for the history of astronomy because what has happened is, well, the more precise your observational, your astronomical observations were, the better your prophecies or your predictions, astrological predictions would be. So there was that connection, but eventually in 1609, jumping a few thousand years here, Galileo comes in and he looks at the sky with this instrument and he sees a completely different reality than people had believed for about 2,000 years, at least, where the Earth was the center, right? And the moon and the sun and all the planets and the stars circled the Earth, and the Earth was static in the center of everything. And Galileo shows that there is a lot of evidence out there, once you start looking with a telescope, that that's just not the real story, right? That the real story is different. And for example, he sees Jupiter, and with his telescope, he could see that Jupiter had 4 artificial, he called them Medicean stars, right? Because Cosimo de' Medici II was the ruler of Florence at the time. He wanted to gain favor with the patron. And so, hey, I'm going to call those new objects that nobody had ever seen before your stars. And it worked. He became the court mathematician for Cosimo de' Medici in Florence. So smart guy, he got a very nice grant, so to speak. And also he basically started a big time revolution. What Copernicus had done 60 years before was a theoretical idea that, is not the Earth, but the sun who is the center of the cosmos, right? But he didn't really have a lot of compelling evidence, and Galileo started the process. Why? Because of this instrument. So, and also just to give a different example, in the 17th century, at the very end, not in the 1670s, Van Leeuwenhoek in the Netherlands invented the microscope. And there again, a whole new universe of possibilities was revealed to the human imagination because this instrument amplified our reach into the unknown, right? We are able, for example, to look at a drop of water and see that there were nice, invisible to the eye, little creatures swimming about, right? So the whole notion of what is life, what are the limits of life, was completely revamped and reinvented because of this. So the history of science and the history of our scientific narrative depends very much on our power to observe nature in more and more detail. And that's why I have, on the left here, I have the Hubble Space Telescope. I should update and put the James Webb Space Telescope now. And you have an array of radio telescopes. And on the bottom right, you have the detector called the Atlas detector, which at CERN looks for the smallest components of matter. So this is an amazing story of achievement, but it's also a story that teaches us something very fundamental about reality, which is that every tool, it doesn't matter which tool it is, increases our range but of what we can see, but also has a limited precision, a limited range, right? So we can see more, but we cannot see all. So there's always something else, something new to discover as we increase the reach of our instrumentation. And that's why, scientists are always trying to get higher precision measurements with better equipment so that we can find what sort of new little piece of reality hides within the cracks of what we could see, right? So as we can see a little better about things, we can dive a little more into those cracks that were invisible to us before and perhaps discover something new about reality that can be revolutionary, such as with Galileo it was, and with Van Leeuwenhoek it was, and certainly with the Hubble Space Telescope or with the CERN accelerator, where we found the Higgs and a bunch of other new particles. And so that is the function that we talk about here. And what does that tell us? It tells us back to the question of truth and the nature of reality. Well, within this cosmic narrative, if you were talking to a person from the 1500s and you ask, what kind of universe do you live in? They would say, well, bottom left, Earth in the center, those perfect crystal spheres surrounding the Earth, and they move about, these crystal spheres move about, and they carry the planets, and they carry the moon, and they carry the sun. The outside, the outermost sphere is the sphere of the stars, and then beyond that, due to Aristotle, there was another sphere called the primum mobile, the first motion, because that is the one that, according to him, was responsible for bringing motion from the outside in. And that is why, the Catholic Church embraced Aristotelian ideas so completely, because it made a lot of sense with their theology, to have the Earth at the center. The Earth is where all the changes, material changes happened. And then as you move outside of the Earth with the moon and all the planets, etc., everything is made of a fifth essence, not earth, water, air, and fire, but the fifth essence, the ether, which is eternal, immutable, perfect, and hence God, of course, would inhabit outside the primum mobile on this new sphere called the Imperium. And that is where God and the elect would rule from the outside in. So it made a lot of sense, right? And that was the vision of the universe then. But then, of course, when you go to Galileo and the 17th century, that is completely changed, because now the sun becomes the center. So you ask yourself, well, what is truth then? Which universe do we live in? Well, it depends on the context of the narrative, the cultural context in which you're asking that question. If 500-600 years ago, he had one answer, and with the discoveries of the 17th and 18th century, he had a different answer. And now, of course, bottom right here, we have this beautiful picture, which was taken by the Hubble Space Telescope. It's called an ultra deep field picture. So basically what they do is they train the telescope into a very, very small region of the sky, and they go very deep. They collect light from objects that are very far away. And each one of these objects that you're seeing in that picture, some of them obviously look very blurry, and those are galaxies. But it turns out that every little dot that you see there is a galaxy, right? And that is just remarkable, because we live in a galaxy, we now know, called the Milky Way. And our galaxy has about 200 billion stars. The sun is one of them, right? And now you look at this universe and you see how our expansion of reach has multiplied, because we can see so much better with the instruments that we have, right? And we say, aha, it is this universe that is being revealed by the Hubble and by the James Webb Telescope and by all the giant spectacular telescopes that exist, that is the real universe. But if you look at the history of knowledge, right, any statement about the real something or the truth of something is a very dangerous statement, because yes, what we see of these galaxies, they're not going to go away for now, right? But there is much more to the universe than just that we're seeing, right? And those questions could change our conception of the universe, as I'll explain in a second. This is the same picture, just in all its glory for you to see for a moment, all right? And just switching pictures a little bit, the question of the material reality. So it will go from the very large to the very small. Even before we go there, one of the fundamental aspects, let me go back to this picture, one of the fundamental aspects of our narrative of cosmology now, which is the study of the universe, that those galaxies, They are not really static, but they are expanding, meaning they are moving away from one another. They're receding from one another. And we have discovered in 1998 that they are receding at speeds that are accelerating in ways that we do not understand. So we do not understand. We know they're doing it. We know they're moving away from one another, and they're doing it at an accelerated rate. We invented a name to describe the effect that we're observing about this, which is called dark energy. Some people even call it quintessence, which is the fifth essence. And you go, oh boy. So we go back to the Aristotelian fifth essence. There's some stuff in the universe that is responsible for this accelerated expansion that we don't know what it is. But the reason I bring this up, which is very interesting, is that if this acceleration continues, and we cannot know if it will continue or not, but if we extrapolate it to 1 trillion years from now, or many billions of years from now, everything in astronomy is billions, right? So many billions of years from now, what will happen is that they're going to be so far away and moving so fast that they will not be visible to us anymore. So our descendant astronomers of billions of years from now, when they look at the sky, they will only see the stars which are closer to our neighborhood. Like, you know, Orion won't look like Orion anymore because stars move, but they'll see those dots of light out there, but they'll think that that's the whole universe. So that is wild, right? Because that shows that if you wait long enough, what we call the universe will be completely different from what we're calling the universe now. So we live in this very privileged time in the history of knowledge, really, where we can see all this richness in the universe. Our previous astronomers couldn't see any of that because they didn't have the tools. Our future astronomers, if humanity even exists, we have another 100 years, I would say, you know, to kind of figure out what we're doing here, and if we're going to actually continue this project of civilization or just really mess it up big time, which is another talk. But the point is, if you wait long enough and the universe continues to accelerate its expansion, those things will disappear, right? And you'd see a completely different universe again. All right. And of course, and then the material, right? What is the stuff that makes everything? And very quickly here, you know, you have a picture. This painting is a painting by Rembrandt. And if you know anything about Rembrandt, usually, you know, especially his self-portraits, this is one of his self-portraits, tend to be very dark and gloomy. He does not look like a happy guy at all, right? But this one is a painting of Rembrandt laughing. And why is that? Well, because the name of this painting is a self-portrait in the image of Democritus. Now, Democritus was one of the pre-Socratic philosophers of ancient Greece. He was an atomist that was a real hardcore materialist, right? So he did not believe in any kind of deity or anything like that. And he believed instead that the belief in superstition was what enslaved the human mind, that once you get rid of that, you would look at reality with a laughing gaze. And hence, Rembrandt apparently liked that. But Democritus also said, kind of like Einstein said, the following, that in reality, we know nothing, for truth is in the depths, right? And the notion here is that we can only approach reality to a certain extent, and we can never get to what's going on. You know, it's all very elusive. We improve, but we cannot get there, right? If you look at this story of what is matter made of, right? I mean, again, it depends when you ask, right? So in the 19th century, there were no atoms. They were conjectured, but we didn't know they existed. But then we found out that they do. And then in 1897, J.J. Thomson in Cambridge discovered that the atom was breakable as opposed to the Greek atom. The real atoms are made of smaller stuff. So there's an electron, and then there was the nucleus, and the nucleus was made of protons and neutrons. And then later on in the 50s and in the 60s, people discovered that the protons and neutrons were also breakable into smaller things called quarks. And the quarks were stuck inside these protons and neutrons. by particles called gluons. They sort of glued the quarks inside. And that's why you see in this picture of the proton there, that you have three balls inside a bigger red ball. All those balls are the quarks. And what's gluing them together is these so-called gluons. And so the narrative, what is matter made of, depends on what you can see of the world. The narrative of what is the universe you live in depends on what you can see of the universe. And so that is a constant in our history of inquiry, so to speak. So right now, if you were to ask, okay, what is the universe made of? You say, well, actually, it's a very mysterious thing because there are three main components for the universe. There is the stuff that we understand and that we are made of, right? The 92 atoms of the periodic table, plus all the artificial ones, but the ones that occur naturally, that is only 5% of what there is. So all the stuff here on planet Earth and the helium and mostly hydrogen and the sun and all the stars, all the materials in the universe are only 5% of what's there. Okay. And the rest, well, I mentioned the dark energy, this substance or whatever it is, we still don't know, that is causing the accelerated expansion of the universe. That is almost 70%, it's at 68%, right? And then there's dark matter, which is possibly particles or blobs of stuff like rocks or asteroid-sized things we don't quite know yet, that only interact with other kinds of matter via gravity because they have a mass. So mass attracts mass, but they have no electric charge. They don't emit light. That's why it's called dark. And we know they're there because of their effects, their gravitational field pool acting on matter that we can see can affect its behavior. And so we see it indirectly, right? So there you have it. After all these advances in science, we are now in a position where we know the recipe. It's sort of like, look, you can make a cake. You have 3 ingredients. One of them, I know very well, it's flour, but that's only 5% of the cake. And then I know that there's some other ingredient, which is 27% of the cake. And the other one, which is 68% of the cake, I know how much you have to put of that stuff, but I don't know what that stuff is. That is the universal cake, the cosmic cake right now, right? And of course, as you go deeper into the nature of the material, the questions become even more profound because you have to deal with the reality of quantum physics. And I have been writing for a publication, a weekly publication, is actually a very good online journal called Big Think. And I have a weekly column with them. It's called 13.8. So it's an heir of the 13.7 from NPR that lasted, I don't know, 11, 12 years. And we now migrated to Big Think. And for the last 10 weeks, I think, or 7 weeks now, I have been talking about the early history of quantum physics, how those European and some American physicists tried to make sense of what was going on when they looked at experiments describing the world of the very small. And if I would summarize the emotional state of these folks, I would say it was complete bafflement and anger because their view of reality, again, the way they thought the world was, using classical physics, the laws of Newton, of motion, of gravity, and the laws of electromagnetism, that was totally fine to describe certain things, but certainly not to describe the components of matter. So again, the narrative of reality had to be updated. And finally, very briefly, because I'm going to explode my time, obviously, one of the most profound questions you can ask is, what is the nature of consciousness, right? And Descartes tried to solve the problem by separating matter and spirit and create essentially 2 different things or objects with different properties. So matter has extension, the spirit has no extension, and he tried to solve the problem that way. nowadays, we try not to do that. We try to understand things within the material perspective of reality. And so cognitive neuroscientists and philosophers of mind are trying to figure out how is it possible that matter can think, right? If you go back to the previous slide and you're thinking by, wow, everything is made of atoms, protons, electrons, and they get together into molecules, and molecules get together into cells, including neurons, which are the cells in your brain. Those cells are connected by synaptic links, and somehow those interactions create you, or what you identify as you. And tomorrow morning when you wake up, barring some horrendous accident, you will still be you, right? And the question is, how can that sense of subjective identity emerge from a chunk of material, right? So that is one of the most profound questions you can ask. And you can diverge into many different ways in which you can take this kind of conversation. For example, you could ask, is it possible to mimic the properties of the brain into a machine and make a machine think? And there was a big, big commotion in 1996 and 97 when the then world chess master, Garry Kasparov, first he won in 96, but then he lost to this IBM computer called Deep Blue, right? So like, wow, are these machines thinking now? Are they going to become more intelligent than we are? And there's a whole big market out there of people that sell lots of books saying that the age of artificial intelligence will come when, you know, the machines that we are creating are going to become smarter than we are. And they are going to develop, this is very important, they're going to develop a sense of autonomy and self-awareness, and then are going to understand that they exist. And once they do that, being so powerful, they may become an existential threat for humanity. So like people like Elon Musk and Stephen Hawking and some others would say that that would be our last invention, you know, an AI that is called a general AI, that is a machine that can actually think and think in ways that understands that it exists. And because once you know that you exist, the assumption is you want to continue to exist. And in order to continue to exist, you have to gather the resources that will allow you to continue to exist, right? And once you do that, you're going to look around, they're going to say, okay, what are the resources I need? What are the impediments for me to continue to exist? And that is what this extrapolation is telling us. But then, of course, we have zero, I will emphasize, we have zero understanding of what does it really mean to be conscious. We have zero understanding that machines can actually mimic anything more profound or subjective that the brain can do. They can mimic a lot of stuff because it's not the machines that are intelligent, it's the programmers that are intelligent. And yes, we have neural networks and machine learning programs now that create its own ways of solving issues, which is amazing, right? And to the point that Google had a machine that defeated the world champion of Go, this Chinese game. And the programmers did not even know what sort of strategies were developed by the machine to do so. But then again, this is a machine that only does that. And it would be very boring to imagine an intelligence that can only play Go or chess and call that a machine that can exist or that has a sense of self-awareness. It's a gigantic extrapolation that we cannot really make at this point. You know, so the questions persist, you know, why or how are you, right? And what is consciousness? And some people now talk about panpsychism, the idea that the whole consciousness is a fundamental property of the universe, just like matter and electric charges. I don't know what to say about that. I don't even know how to think about what does that even mean from a physics perspective, but it's kind of a cool idea, right? And the point is that we cannot know. So how do you summarize all this? I'll skip that part of the simulation. Well, so years ago, I wrote a book, which I called The Island of Knowledge, which was my attempt to summarize all the main themes of this conversation. And the idea is very simple. Imagine that everything that we know of the world fits within an island, right? And that is, of course, the island of knowledge. And that knowledge can be about the world outside, can be our world inside, it can be our creative outputs through arts and many other things, but that is the sum total of what humanity has done to figure out its existence, right? Now, of course, since this is an island, every island is surrounded by an ocean. And in this case, since this is the island of knowledge, the ocean around it is the ocean of the unknown. And the paradox of knowledge, which is the sub-theme text that I've been bringing all along here, is the following, is that the more you know, the more the island grows. And you say, aha, that means that eventually this ocean of the unknown is going to disappear and we're going to figure things out, right? But that is not possible because as the island grows, the boundaries between the known and the unknown, the periphery of the island, also grows, which means that the paradox of learning, of knowing, is that it creates more not knowing. The notion that as you become equipped with new knowledge, you immediately start asking questions that you couldn't have contemplated before. Back to our examples of the microscope, of the telescope, nobody could figure out that with these instruments, we would amplify our vision of reality to a point where new questions came up, right? So what do you do with that? Well, you are humble and you understand that the quest is what matters, right? And so more than that, that you cannot really talk about the final truth about physical reality because you don't even know what questions you're going to be asking about reality in 2 weeks, 10 years, 50 years, we have no idea, right? It is not something you can predict. And so the quest is the point. And even more interestingly, is that in this ocean of the unknown, you have the realms of the unknowables. So there are fundamental questions you can ask about the nature of reality that you cannot answer with the science as we understand it right now. Many examples, some of them more metaphysical, others less. For example, the Big Bang. Can we answer through physics what the Big Bang was? Well, you can make models of reality, that could describe the properties of the universe that we can measure. But how can you possibly know that those models of reality are really corresponding to what truly happened there? You cannot. The best that you can do is the best that you can do, right? So the final understanding of questions like that does not seem to be a property that scientific theories may have, even if I spent decades of my life kind of working on this. You have to understand that what we do is the progress in increments that do not approach a final answer, right? And other questions, same with the origin of life on Earth. You can have theories about it. You can even reproduce life in the laboratory, which we have not been able to do at all, by the way, but you cannot know that that's what happened on Earth about 3.5 billion years ago. And there are many, many other examples that we don't have time to go to. So when you think about that, people sometimes get a little deflated, say, oh, what a bummer, right? I mean, so does that mean that I'm wasting my time, that I'm working so hard on stuff and I cannot get to the end of things? But the point is that those limits of knowledge, they are precisely the challenges that we need to move forward. It would be much worse if we woke up one day and said, yep, we got it. We figured everything out. We're done. That to me is a much more horrendous alternative, almost dystopian, than to understand that we are in a quest, and it is the search, is the ability that we have to search that makes us matter. So much meaning can be obtained by asking questions and trying to figure them out, even if you have the humility to accept that not all questions are answerable or have a final answer, right? So when you put this all together, you realize that the map of what we call reality is truly an ever-shifting mosaic of ideas, right? We are changing the way we're looking at the world as you change the way you look at the world. And that, of course, impacts how we see ourselves as humans in this universe, how we see ourselves in this planet, in this moment in history, which is a crucial moment for humanity, where we have to rethink profoundly our relationship to the biosphere, to one another, and to really develop a new ethical way of being in this planet, right? But that, of course, is a different story. And if you want to know a little more about the things that I talked to you today, these are a couple of books that could be useful. And I thank you very much for your attention.
Thank you very much, Dr. Gleiser. Very interesting. We have a respondent who's ready to provide a response to what Dr. Gleiser has just presented. And his name is Rabbi Robert Freeman. Rob is an experienced spiritual counselor, a ritual creator, and prayer leader, a Reform rabbi and scholar of Hebrew Bible, Judaism, Jewish history, and the Jewish ethical living curriculum of Musser. He brings an academic approach to the history of Judaism and how we can apply it to our modern daily lives. Rabbi Freeman's passion and call is to help each person he engages with to continue the process of improving their day-to-day lives. He's a strong believer in the power of tshuva, the Jewish concept of redemption, and he's dedicated to modeling in word and action how transformative that process can be. As a former military chaplain, Rabbi Freeman has extensive experience working across faith settings, and he brings an authentic, pluralistic mindset wherever it's needed. He currently resides in the greater Chicago area with his wife, Robin, and dog, Kimber. And Rob, before I turn you loose, I want to remind people that they should put questions. We have lots of questions already coming in. Make sure that you're putting them in the Q&A. If you put them in the chat, I can't see them, and so they won't get asked. So if you put questions in the chat already, please move them to the Q&A so I can see them and we can get them to our presenters. So with that reminder, Rabbi Freeman, please go ahead.
Thank you, JD, and thank you, Marcelo. Before I get into my response, I just want to say, Benzoma Omer Ezehu Hacham Halamod Mikol Adam. Benzoma says, who is wise? One who learns from everyone. And I can't speak for the rest of the people on this call, but I am definitely wiser for the talk that you just gave, Marcelo, so thank you. You started with an Einstein quote, and so I too would like to start with an Einstein quote. The pursuit of knowledge for its own sake, an almost fanatical love of justice, and the desire for personal independence, these are the features of the Jewish tradition that make me happy I belong to it. And I find this quote very fitting because the pursuit of knowledge for its own sake is in fact a very key and central point of being Jewish. And for Einstein, it was a key part of his identity. And so this notion of pushing our limits, of expanding our island of knowledge, I find personally through my Jewish lens to be a very core Jewish concept. In Arabic, for instance, Jews are known as Ahl al-Kitab, the people of the book. And it's very fitting because we have books upon books upon books. We have the Torah, the Hebrew Bible, the Mishnah, the Talmud, and all of our commentary. And we study it and we build on it and we study it and we build on it to the point, I'm going to see if I can, actually, I'm going to share my screen for this. That what we have right here is a page of Talmud, a page of Jewish law, of Jewish text, that ranges from the 2nd century of the Common Era all the way into the 11th century of the Common Era. And we don't need to go into what all is on this page, but merely to say that each different color that we see highlighted, starting with the innermost, that off-red color, and expanding outward, is different generations all engaging with the same text. It's rabbis talking to and about rabbis from potentially hundreds of years prior. So I'm going to turn that off. And what I find so fitting with this and relevant to your talk is that this notion of studying over and over and over again is, as you put it, diving deeper into being able to see the cracks. That as we engage more and more, and we build on previous explanations and explorations, we can interact deeper. And there's a 20th century rabbi, a great 20th century rabbi by the name of Abraham Joshua Heschel.
His daughter is my colleague here, Susanna Heschel.
She is absolutely wonderful.
Yeah,
she's absolutely wonderful. I've had the privilege to hear her speak.
Yeah.
And her father, Abraham Joshua Heschel, writes extensively about this phrase that he calls radical amazement. And that he says, quote, "Our goal should be to live life in radical amazement, to get up in the morning and look at the world in a way that takes nothing for granted. Everything is phenomenal. Everything is incredible. Never treat life casually. To be spiritual is to be amazed." Parallels in my mind very fittingly with that second Einstein quote that you shared with us. And Heschel continues on in his book, Man is Not Alone. He writes a lot about wonder, about knowledge and doubt. And he says that standing eye to eye with being as being, we realize that we are able to look at the world with two faculties, with reason and with wonder. And through the first, we try to explain or adapt the world to our concepts, I would say paralleling Heisenberg. And through the second, we seek to adapt our minds to the world. Wonder rather than doubt is the root of knowledge. Doubt is one of auditing the mind's accounts about reality rather than a concern with reality itself. It deals with the content of perception rather than with perception itself. And all of this I find to be a wonderful and incredible parallel to the scientific process and the scientific mind of studying the world around us and how we engage with that process. Before I get to my question, which ties into Heschel, I just want to say that this notion of how does matter think, how can the sense of subjective identity emerge from that chunk of material, I'm very interested to see how we're able to scientifically categorize and define what we might call the soul from a religious perspective. And so I'm very interested to see how that work goes.
Yeah, well, everybody is. It's like one of the, it's like, how do you do that, right? And it's a phenomenal and very fascinating question.
Yeah. But so my question, with the honor of having the first question and to move this along, is I'm curious as a scientist and as a theoretical physicist who studies extensively this question of the limits of knowledge and the island of knowledge, and who is acutely aware of our human limitations. How does one maintain and cultivate that sense of wonder and radical amazement that Einstein and Heschel talk about, when one could just as easily look out on the vastness of the unknown and the unknowable and instead become disheartened, disenchanted, and jaded towards the pursuit of more knowledge?
Right. So that is a very good question. And when I published this book, I had lots of my physics colleagues say, but that's so defeatist, because what's the point? It sounded like the Woody Allen thing. I don't want to go to school anymore because, the universe is going to end, and so it's, what's the point, right? And the point is that in the pursuit of knowledge, right, you expand yourself as a human being and you become more of who you can be. So as you learn more about the world, as you ask questions about the meaning of knowledge and the meaning of life, and why do you do what you do, you sort of expand your presence in this world. And life is such an ephemeral and fascinating gift that it would be a true waste, like the snuffed out candle that Einstein mentioned, to actually live a life without being curious about questions, being curious about what it means to be here, to be alive. I always tell people that everybody should live a life with a sense of mission, right? I'm sure that you have a sense of mission, and I'm sure a lot of our audience has a sense of mission, meaning you wake up in the morning and you know that there is a reason for you to be in this world. And if you don't have that reason, there is a reason for you to search for the reason to be in this world, and by this quest. That's why I said it is wanting to know that makes us matter, because by engaging in this pursuit of knowledge, you not just expand your presence within humanity, but you also influence and inspire others, right? And what could be more noble, for an individual than to do that, to expand your circle of knowledge and invite other peoples to learn with you, right? So I think that is essential. And then, of course, there's this whole other dimension, which is not as pragmatic, which is the sense of awe with the mystery of existence, which is very kind of abstract notion, but it's also one that, William James would say is at the core of every religious feeling, right? The notion that what is this conversation that each one of us will have or already has, with this presence, which you can call different names, you can think of it in different ways, but that is so inviting, to your questioning of who you are, and so this is to me the core of the religious feeling, and that is what in my case spirituality means, is this engagement with the mystery of existence.
Thank you.
Welcome.
So thank you, Rabbi Freeman. That was very interesting. I'm going to get right to the questions. We have more questions than we have time for, and I'm going to start with a question from Saul Katz. He writes, if you would, can you compare your perspective with that of biologist Ursula Goodenough, the author of The Sacred Depths of Nature? I don't know if you're familiar with that book, or maybe with religious naturalism.
Yes.
Can you speak on that?
Yeah. So I know Ursula. Actually, Ursula was one of the contributors for 13.7, that blog that we had at NPR. She was one of our first people we invited. So I've exchanged a lot of thoughts and ideas with Ursula, and I have read her book, and I'm also part of that society. I'm a member of the Religious Naturalist Society as well. So yes, I would say that Ursula's work is really a love affair with the beauty of the natural world, and it's very sincere and very deep and very honest, and it's profoundly spiritual as well. So I would say that she finds her drive for a spiritual life in her connection with the mystery of life, which is the focus of her world. And I think that's just beautiful. And I would say that my perspective and her perspective are in a sense very similar because we're both connected with the spiritual bond that we have to the awesomeness with the right sense of awesomeness of being here in this place, you know, and trying to figure things out. So yeah, so Ursula is a very dear friend, and I think that's a very apt connection there.
Elizabeth Bjorkman asks, you make the argument that religion and politics too need to keep looking beyond cultural boundaries, which are limiting us. More of a comment than a question. You want to say any more about that?
Sure. I think that that's a very important comment for our times, right? Because we have, by evolutionary and historical needs, so to speak, we kind of evolved to think in terms of being members of a tribe, right? And we have allegiance to certain tribes, and of course, this notion of being a member of a tribe has been extremely useful in many ways and continues to be in many ways, but it also can be very detrimental to our survival as a species because it does not see humanity as a single tribe above all other tribes. So if there is any big lesson, you know, and I just finished a book that will come out in August, which kind of is a book that calls this whole conversation into question, you know, how do we do this? How do we come out of this mess that we are in? And one of the points is that we have to expand our understanding of what we mean by being human, to really belonging to this tribe of humanity, you know, and that we are together as a species and not as separate little groups, you know. So absolutely. And this is the moment to bring down those walls and embrace each other.
Yeah. Chuck Fowler asks, given the prevalence of patterns and structure in what we observe, would you please expand on the concept of emergence?
Oh, wow. Yeah,
That's a big question for sure.
Yeah, so emergence there was this very famous physicist from Princeton called Phil Anderson, who wrote an essay, which you guys, everybody can read. It's called More is Different. And the idea is that many properties of physics, but not just in physics, they are not reducible to the fundamental components of what this stuff is, but they emerge as properties of groups of things. For example, the notion of temperature, right? So where does temperature come from, right? So from a physics perspective, temperature comes from if you have a gas in a volume, and there are a bunch of little molecules moving about. The faster they move about, the hotter they are. And there is a connection between the average square of their velocity and what we call temperature, okay? And why am I bringing that up? I'm bringing that up because the notion of temperature, which is so familiar to us, only makes sense when you talk about many, many, many particles interacting with one another and moving about one another. If you took one or two or three particles, you can't talk about temperature.
It's
So
not temperature, it's speed at that point.
Yeah,
It's velocity.
based on temperature, right? So temperature as a notion that we talk about qualitatively is really an emergent property that only appears when you have many particles. And there are other objects like that. And there are certain, as he mentioned, you know, the many patterns that appear. So you look at the shape of a hurricane, and you look at the shape of when you're taking a bathtub and you unplug it, you're going to see the water swirling in the middle there, and the storms in Jupiter, all these, the eye of the storm, so to speak. Those patterns, you know, they also respond. They appear in different physical situations, but they are a way in which matter self-organizes in the most energy efficient possible way, given the circumstances. So patterns tend to be a response to a combination of stresses and energy efficiency. And you can see, to me, one of the most fascinating patterns is how things fork, right? So you think about a tree, right? The tree, the trunk is this way, and then the roots fork out into many different roots. And then, of course, the branches also fork, and they keep forking. And you look at our bodies, we have a main trunk, and we have our roots that fork, our legs and our toes, and then we have our arms and our fingers that also fork. So you have a forking in the human body and all pretty much most of the animals. And you see that in rivers, and you see that in our arteries and our veins and our nervous system. So forking clearly is a way in which you can maximize the transportation of things into many different places, right? And that's why this pattern appears. It's a combination of the stress of, I have these nutrients that I need to move about, for example, or water, because of a river, and the amount of resources that you have, right? And so patterns and emergence like that, they're very fascinating, and they seem to kind of be telling us that in 3 dimensions, which is the number of dimensions we exist, nature prefers certain patterns than others because they serve the purpose of energy efficiency, and in the case of animals, of staying alive the best.
Yeah. Jerry Zuli asks if you would speak a little bit about the pursuit of knowledge and the pursuit of understanding, which he sees as 2 very different pursuits.
Well, the pursuit of understanding. So let me see, that's kind of like a semantic nuance there. But, you know, I understand English mostly, and Italian and Portuguese and Spanish, but I would not say that I have a profound knowledge of the history of English language or the etymological roots of, actually, I know few, but not of lots of them, or the linguistic structure of many languages. For that, I would have to study deeper, you know, and so understanding is perhaps the first encounter with something that, if you want to go deeper into, you would require further study to obtain more knowledge. And also, when knowledge is something you create, you obtain, right? And understanding is something you acquire, is a more passive way of relating to information.
Well, here's a question from Thomas O'Donnell that may be related. He writes, I struggle to understand the meaning of the 2-slit experiment. Can you help me understand the reality of the results, particularly the wave particle response when the detector is not turned on?
The which experiment? Say that again.
The 2-slit, the double slit experiment.
Oh, the double slit experiment.
So
Well, you're not alone.
I'm putting those back to back because here's where we have the knowledge of what happens, but we don't necessarily have an understanding of the reality behind it.
I see. So, yeah, that's okay. So that's more of an interpretation of what goes on. So the 2-slit experiment, that, well, you shouldn't feel bad about not understanding because nobody really understands it. We understand what goes on, we see what goes on, we make measurements, but we do not have a theory that explains their behavior, only a mathematical formalism. There's no interpretation. Well, I should say there's no accepted interpretation of quantum mechanics. There are just many different ways of thinking about it, right? So the formalism works, the math works very well. Basically, it's the notion that if you start with water, and you have water go through a wall that has 2 holes in it, some of the water is going to go through those holes and it's going to create these circular waves. And when the waves from one hole interact with the waves from the other hole, they're going to create interference patterns, talking about patterns again, and which will be seen as more water and less water in certain points in space. If you do that with light, you can do the same thing with light, and you're going to see that light goes through these 2 slits, and you have to adjust the size of the slits so that it can affect the propagation of light, because light has very short wavelengths. You're going to find on a screen light and dark patterns as well, which are the interference patterns that happen because of this phenomenon called the diffraction of waves. So waves diffract. right? And what's really awesome, is that if you now do the same experiments with electrons, so now you're talking about little bullets of stuff like matter particles.
At least as we perceive them.
Mhm.
As we have classically perceived them, they're like little bullets.
Yeah, so that's the thing, is that when you subject electrons to a double slit experiment, they will behave as waves. They will also create interference patterns in such a way that you have the probability of finding the electron on a screen to be bigger here and smaller there. But if you now either close one of the screen, one of the slits, or if you shoot another electron or another particle in the direction of those after they go through the slits, they will behave like a single bullet. They'll behave like a particle, like a ball of stuff, you know. So this is the so-called wave-particle duality of quantum physics. And the point there is what is going on. So could the electron, which you perceive as a particle, right, is this little thing moving about the nucleus of an atom, could it also be a wave? And I was just mentioning some time ago that I'm writing this series on Big Think about the foundations of quantum mechanics. And one of the topics was exactly that. What is going on here? And one of the problems with all this is that we are using words, language, to describe a situation that we have zero intuition about. Because, you know, I'm talking about waves and particles because we, in our everyday life, can see waves and particles. So we say, oh,
That's the language we have. Yeah.
right. But you cannot really think of the electron as either a wave or a particle. It is its own thing. And the mathematical formalism that we have, this doesn't describe it as either a wave or a particle. It describes waves of probability of finding an electron in this point or that point. So the language of quantum physics, that's why I mentioned it before, like led to a lot of bafflement, is that it does not tell you that the electron is a wave or a particle. It just tells you what is the probability of finding the electron here or there. And it can behave either or, and this is what's wild, depending on the question you ask. So people go, aha, so does that mean that the nature of physical reality, you know, whether this object is a particle or a wave, depends on how I ask the question? And the answer is yes, because when we humans interact with those electrons, we force them into a behavior that by themselves they may not have, and we cannot tell what's going on. So the difference between an electron and a cannonball, right, is a cannonball, you shoot the cannon, you can see the cannonball is going to go from point A to point B, and you can follow the trajectory of that. But the electron, you can't. As soon as you try to ask, where is the electron in the middle of the way? You don't know, right? And if you ask that question, trying to localize it, you treat it as a particle and it behaves as a particle.
Yeah. If I may try to represent Thomas's thinking behind the question, it sounds like your answer to how to understand the reality of the double slit experiment requires seeing it as a mathematical phenomenon more than as either a particle or a wave. Is that?
Well, I would say
fair?
Something like that, but I would frame it perhaps slightly different. I would say that the narrative that we have constructed to make sense of the results of the experiments that we perform is a mathematical narrative. That makes a lot of sense. Once we start to try to make that narrative with language, you get turned into a pretzel. Yeah.
Well, we're going to have to end there because we are almost out of time. So thank you very much. I wish you could hear the applause.
Yeah.
And I'm going to turn it back over to Maynard, our host, to take us out. Thank you very much, Dr. Gleiser.
Thank you. See you soon.